Good afternoon, everyone. My name is Neha. I'm from IT department. My topic is deep learning for human activity recognition in mobile computing. Introduction. Human activity recognition is the process of identifying and classifying human physical activities like walking, sitting, or running by analyzing data from sensors embedded in mobile devices such as smartphones or smartwatches. Why human activity recognition matters? Enhances the user experience in fitness and health apps, helps in real time health monitoring and elderly care, enables context aware computing. Examples like changing phone behavior based on movement. Role of mobile computing. Modern smartphones come equipped with mo- equipped with the motion sensors. Accelerometer detects acceleration in three axes. Gyroscope measures angular velocity, and magnetometer tracks the orientation. Portable and always with the user, ideal for continuous human activity recognition. Traditional versus deep learning approaches. Traditional machine learning methods relied heavily on manual feature extraction from sensor signals. Algorithms used support vector machines, decision tree, and k nearest neighbors. Limitations. High dependency on domain expertise, limited ability to model complex nonlinear activity patterns. Deep learning approach learns features automatically from raw time series data, works well with large high dimensional datasets, capable of modeling both spatial and temporal dependencies. Example like CNN for local patterns and logical for sequential dependencies. Key benefits of deep learning for human automation recognition is nothing but higher accuracy and less need for manual pre-processing, scales better across different users, devices, and environment. Here we can see the automatic feature extractions and learning. First, the raw data is sent to the manual feature extractions and then learning and then output. This is the traditional approach, and the end-to-end learning is nothing but raw data is converted to automatic feature extraction and learning and gives the output. Sensor data in mobile. Human activity recognition relies on sensor generated data from smartphones, smartwatches, or wearables. These sensors collect time series data reflecting the movement and orientation. Commonly used sensors: accelerometer, gyroscope, and the magnetometer. The accelerometer is nothing but it is used to measure the linear acceleration, that is x, y, and z axis. Detects the motion like walking, running, and falling. Gyroscope is nothing but it captures the rotational motion or the angular velocity, useful for detecting turns and the body orientation. Magnetometer is nothing but it acts like an digital compass, provides the orientation data. Nature of sensors data is nothing but continuous time series signals collected at different sampling rates, like example 50 to 100 hazards. Requires pre-processing like noise filtering, normalization, and the segmentation. Is nothing but the sliding window. Deep learning models used. Deep learning models outperform traditional methods by learning patterns directly from raw sensors data. First one, the convolutional neural network CNN, learning the local spatial net patterns in the time series windows, good at identifying the repeated movements features, like example walking cycles, used ID convolutional for time series input. Recurrent neural networks is nothing but it captures the temporal dependencies across the time. Long short term memory is nothing but is preferred for handling the long term activity patterns, suitable for distributing the activities with similar patterns but different sequences. Third one, the hybrid model, which we can combine the CNN and the LSTM, which is nothing but convolutional neural networks and recurrent neural networks, long short-term memory. Combine the spatial feature extractions like convolutional neural network and long short-term memory and the temporal learning, achieve state-of-the-art results in human state hazard in human hard tasks. Why deep learning? Handles the raw sensors data without manual features, automatically adjusts to signal variations, scalable to large data sets and the real world use. Here we can see the why the deep learning is. System architecture. This slide this slide shares about how the data flows from a mobile devices to a deep learning model to recognize the human activity. System workflow. Sensor first step is the sensor's data flow and the pre-processing and the deep learning model and the activity classification. The sensors data collection, in which the smartphones or the wearable sensors like example accelerometer and the gyroscope continuously captures the raw motion data. And the pre-processing is nothing but it contains the noisy filtering and the normalization and the windowing, which examples like fixed length time segments. Deep learning model is nothing but input windowed like data to a convolutional neural network and long short term memory, or continuous neural network plus long short term memory network. Extracts the features and learns patterns. Activity classification. Model predicts the activity label like walk, sit, run, and stand, etc. Output used by the apps or monitoring systems. These are the challenges: user variability, device placements, limited resource, and the data annotation and the quality. User variability is nothing but different walking styles, body patterns, and movement speeds. And next one is the model may not generalize well without personalization. Device placement. Accuracy depends on whether the device is in a pocket, hand or backpack. Model must be to be orientation and the position changes. And the third one is limited resources. Smartphones have restricted preprocessing powers, memory, and the battery. Large models may not run efficiently on the device. Fourth one, data annotation and the quality. Requires labeled training data for supervised learning. Collecting and the labeling sensors data is time consuming and the error prone. Sensors data in mobile. Human activity recognition relies on sensors generated data from smartphones, smartwatches, or wearables. These sensors collect time series data reflecting movement and the orientation. Commonly used sensors are nothing but there are three types of commonly used sensors: accelerometer, gyroscope, and the magnetometer. Accelerometer is nothing but it measures the linear acceleration like x, y, z and axis. Detects the motion like walking, running and falling. Gyroscope is nothing but it captures the rotational motion or the angular velocity. Useful for detecting the turns and the body orientation. Magnetometer is nothing but acts as a digital compass, provides orientation data. Nature of the sensors data is nothing but continuous time series signals collected at a different sampling rates like example 50 to 100 Hz. Requires pre-processing like noise filtering, normalization and the segmentation. Deep learning models used is nothing but there are three types of deep learning models. First one, the convolutional neural network and the recurrent neural network, and the third one is hybrid models. In convolutional neural network, we learn about the local spatial patterns in the time series windows, good at identifying repeated movement features like example walking or cycling. Used ID convolutions for time series input. The second one is recurrent neural network or long short-term memory. Captures the temporal independencies across time. Long short-term memory is preferred for handling long-term activity patterns, suitable for activities with similar patterns but different sequences. Hybrid model. In hybrid model, which we combined both a convolutional neural network and long short-term memory, combines the spatial feature extraction. Conclusion. Deep learning has transformed human activity recognition. It enables the accurate, automatic, and the scalable detection of activities from raw sensors data. Mobile devices like smartphones and wearable make human activity recognition practical and widely accessible. Convolutional neural network and the long short-term memory extracts the complex and spatial and temporal features, outputting the outperforming traditional methods. Key challenges remain variability in users' behavior, device constraints, and the privacy and the data labeling. Future outlook. Lightweight models for real-time use privacy-preserving techniques like federated learning, multimodal data fusion for enhanced recognition. Thank you.